So good afternoon, everyone. So we will now start the continuation of our discussion in the rad physics. So we have here the modes of decay. So we have different types of decay or modes of decay. We have the alpha, the beta, the isomeric transition, the internal conversion, also termed as the K conversion, as well as the electron capture or the K capture. So these are the five common modes of decay that are very important in our field. So for the alpha emission, so it occurs in heavy nuclides with high atomic number. So if you can remember, the symbol for our atomic number is capital or small letter Z. So it occurs in heavy nuclides or heavy elements with high atomic number. So usually the elements which starts from 74 atomic number and above. So it resembles the helium element because the relative charge of alpha is 2 and the mass is 4. So just like our helium, so the charge or the atomic number of helium is 2 and the mass of helium is 4. So sometimes alpha particles are also referred to as the helium nuclei. It has low penetrating power as compared to other types of particles and radiation, so low penetrating power, but it is most harmful internally and less harmful externally. So less penetrating siya or low penetrating siya, pero most harmful siya internally. Dahil pag nakapasok po siya sa loob ng katawan natin, hindi na po siya makakalabas. Kaya harmful siya internally. Pero pag nasa labas po siya, so hindi po siya makakapasok sa loob ng katawan natin. Therefore, it is less harmful. So minsan, mapasok po ang alpha particles, lalo na po pag na-ingest natin or na-inhale po natin siya. Pero aside from that, mahihirapan po siya mag-penetrate sa katawan natin, kaya less ang kanyang effect sa ating katawan. So it has low penetrating power that it can be stopped by a piece of paper. Kahit papel lang po or damit natin, pwede siyang ma-stop. Kaya kung hindi po siya makaka-penetrate sa ating katawan. So radium, for example, decays by alpha emission. So the parent is the radium. You can remember the previous discussion. So radium is the parent, meaning it is a radioactive element. It is unstable. Then it will decay, it will emit alpha particles. Then the daughter, which is stable atom, is now the radon. So we will have an example of that in a while. So ito siya. So radium, so we will highlight. So radium has an atomic mass of 226 and atomic number of 88. So sabi natin, ang alpha has a mass of 4 and a charge of 2. So dahil we are talking here of decay, so 226 minus 4 is 222, then 88 minus 2 is 86. So how are we going to identify what is the parent, what is the daughter element? Ito po yung parent natin, ito po yung daughter natin. So when we come up with 86, we will check our periodic table of elements and see to it if what is the element that has an atomic number of 86. So sabi nga natin kanina, bawat element has their own distinct, unique atomic number. So nag-iisa lang po ang element na may atomic number na 86. At yan po ay radon plus alpha particle which is emitted after the decay process. For beta decay, for example, it has two submodes, the negatron emission or the negatron decay or the beta minus decay, and the second one is positron emission or the beta plus emission. So relative charge of beta is -1 and has no mass. So if alpha has a charge of 2, positive 2, and mass of 4, the beta decay or the beta emission has a charge of -1 and has a mass of 0. So no mass po siya. So mas magaan po siya as compared sa alpha particles. So it has a moderate energy as compared to sa alpha natin, and it can be stopped only by approximately 0.5 millimeters of aluminum or lead. Unlike po sa alpha natin, it can be stopped by a piece of paper or cloth. Ang beta decay po, pwede po siya ma-penetrate sa paper and sa cloth. And materials that can stop it must be at least 0.5 millimeters of aluminum or mas pwede din po ang lead. So to some mode are the negatron emission or the beta minus or the beta decay, beta minus decay. This occurs when there are too many neutrons. Pag marami pong neutrons sa loob ng nucleus, mas marami po siya as compared sa protons. So magkakaroon po tayo ng negatron decay. So it will emit its extra negatron. It will emit its extra neutrons. So negatron is a negative electron coming from the proton. Coming from the nucleus. Sorry. Again, negatron is a negative electron coming from the nucleus. So iodine-131, for example, decays through beta negative emission to xenon-131. So here we have iodine-131. So if you have noticed, wala po changes sa ating mass. 131 pa din because sabi natin, beta has no mass. And dahil marami po siyang neutrons, kailangan po niya mag-give off ng neutrons. So, pag nag-give off po siya ng neutrons, kailangan po mag-add tayo ng isang proton. Or kung hindi po siya mag-give off ng neutrons, kailangan po maging stable siya. So, we have to add up one proton. So, here, 53, which is the number of protons, so plus 1, it now becomes 54. And if we check a periodic table, the element that has an atomic number of 54 is xenon, plus electron that comes from the nucleus. Don't be confused. Yung electrons po na sinasabi natin last time sa ating discussion ay yung mga electrons na galing sa shell or sa orbits. Pinag-uusapan po natin dito ng electrons are the ones coming from the nucleus. Yes, there are electrons po na galing sa nucleus. Yung mga minute, yung mga na discuss po siya sa quantum physics. Mga quarks, muon, marami po yan. Marami po siyang klaseng particles inside the nucleus. Hindi lang po protons at saka neutrons. So, electron, negative charge, also comes from the nucleus in this type of decay. Okay? For the positron emission, so it is a beta plus decay. It occurs when the radioactive material has an excess number of protons. So it has to give off its extra protons. Pag hindi naman po siya nag-give off, so kailangan po niya mag-decay ng kanyang protons. The particle emitted is called positron. So positron is a positively charged electron coming from the nucleus. So galing po siya sa nucleus, okay? Positively charged electron from the nucleus. So example, gadolinium 2C. So the parent is gadolinium, the daughter is zinc. So bakit kamo? So ito po yung ating mass. So no change dahil no mass ang beta. Dahil sobra po ng protons, kailangan po natin magbawas. So 31 minus 30. 31 minus 1 is 30. So in our periodic table, 30 atomic number represents the zinc plus electron. Okay? So you have to remember, pag negatron decay, negatron siya negative but plus 1. Dahil kulang po siya ng protons. Pag positron emission naman, dahil sobra naman ng protons, minus 1. So parang baliktad po siya. So instead po na minus 1 sa negatron, nagiging plus 1 po tayo. Okay? So sa mga nahihirapan pong intindi or parang naguguluhan pa po, you can email me or chat with me sa Facebook po to ask me about more of this or to let me explain it to you further, okay? Then for isomeric transition, so it emits gamma rays and only occurs in elements with excited state. So if you can still remember, isomers, ang sabi natin kanina, the previous discussion po natin, isomers are elements that have the same atomic number, the same atomic mass, the same element, but they differ in energy levels. So during emission, there is no change in the number of particles of the excited nucleus. So during this decay, during this isomeric transition, wala pong changes sa mass, walang changes sa atomic number, wala din pong changes sa type of element. Yung change lang po niya is kanyang extra energy. The excited nucleus upon emission of gamma radiation reaches its ground state. So, sa isomeric transition, para po maging stable siya, yung ini-emit niya pong particle or radiation is in the form of gamma rays. Sa alpha po, yung ini-emit niya is alpha particles. Sa beta, beta particles, or the electrons coming from the nucleus, the negatron and the positron. Sa isomeric transition naman po, yung ini-emit po niya ay gamma rays. Okay? So when we say gamma rays, these are electromagnetic radiation with no mass, no charge, and travels at the speed of light. The speed of light is constant at 3.0 times 10 to the 8 meters per second. So, ang ating pong gamma rays, wala po siyang mass, wala rin po siyang charge. Ang alpha po natin, yung mass niya is 4. Yung charge niya is 2. Yung beta po natin, mass is 0, also no mass, and the charge is negative 1. Ang gamma rays naman po, no mass, no charge, and the speed is constant, the speed of light, which is 3.0 times 10 to the power of 8 meters per second. These are uncharged, no charge na, uncharged electromagnetic radiation of high energy and high penetrability emitted from the nucleus. So, uncharged siya, tapos may pinaprocess po siyang high energy. So, if it is having high energy, therefore it can penetrate also higher. So, it has increased penetrability. So, it comes from the nucleus. So, alpha, beta, and gamma comes from the nucleus. So, gamma rays is the only nuclear electromagnetic radiation. Lahat po ng klase ng electromagnetic radiation, which we will discuss further in this discussion, lahat po ng klase ng electromagnetic radiation ay galing po sa orbits or sa shells. Lahat naman po ng galing sa nucleus na particles ay tinatawag, ay kinoconsider na particulate type of radiation. Pero, ang gamma is an exception. It also comes from the nucleus, but it is not considered as particulate. Dahil ang gamma rays hindi siya particulate, it is considered as electromagnetic radiation dahil ang kanyang pinaka-characteristic para maging nuclear radiation, electromagnetic radiation ay ito. It travels at the speed of light. So, any radiation that travels at the speed of light is considered as electromagnetic radiation. Yung ibang radiation or yung ibang particles na nagtatravel at different speeds, so pag iba po yung speed nila, so it is considered as particulate type of radiation. So, number 4 is the internal conversion or K conversion. It is defined as a removal of an electron within an atom by a gamma ray from a nucleus. During internal conversion, X-ray is also emitted because an electron from relatively outer orbital replaces the vacant space left behind by the ejected electron. So, it replaces the ejected electron, and because of that, it also emits characteristic X-rays. So, in a while, we will also discuss how characteristic X-rays are produced. So, the electron rejected is called as conversion electron. So, pag sinabi po natin internal conversion or K conversion, ito po ay removal of electron within an atom by a gamma ray from the nucleus. So, halimbawa po, meron po tayo dito illustration. So, when we say internal conversion, by internal conversion, removal of an electron within an atom by a gamma ray from the nucleus. So, for example, ito po yung atom natin. Ito yung mga shells nila. So, dalawa, 4K shell. Let us assume this is 8. Halimbawa, 8 po siya. Ito naman is, let's say, 4. So, when this, erase natin ito, gawin natin. Ito natin halimbawa, nandito po yung nucleus. Ito po po yung nucleus natin. Nucleus po siya, radioactive nucleus. So, mag-i-emit po siya ng gamma rays. Dahil kailangan niya maging stable. So, these are gamma rays. There are times, yung mga gamma rays na ito, hindi po siya diretsong lumalabas mula sa atom. So, may iba po na gamma rays na nag-ionize nitong electron. So, when we say ionization, removal of electron. So, nire-remove po ng gamma ray na ito ang electron from this shell. So, natawag po siyang K-conversion or internal conversion. So, this electron here will be ejected. The ejected electron is now called conversion electron. So, conversion electron po ito. At dahil kulang po, hindi po ba, if you can still remember, hindi po pwedeng kulang na electron sa loob ng shell. Okay lang po kung kulang ng electron sa last shell. Pero pag sa loob po siya, hindi po pwedeng kulang. So, dahil kulang, there will be filling up. So, may filling up po na mangyayari. Dahil kulang, yung electron from here will transfer here. Dahil siya, pumasok siya dito, i-replace ko siya dito. So, therefore, wala na pong electrons dito. Sorry. Wala. So, ito po, wala na pong electrons dito. Pumasok na po. During this filling up, yung pag-transfer po, sometimes yung term po is filling up, transfer, or transition of an electron from outer to inner. From outer to inner. During this filling up, there will be emission of an extra energy. So, may energy po dyan na maiinit. So, may energy din po. This energy is referred to as the characteristic X-ray. So, therefore, internal conversion or K-conversion emits gamma rays. At the same time, because of the filling up, kasi kulang na po ng electron sa K-shell, it also emits characteristic X-rays. So, dalawa pong ini-emit niya. Sa alpha po, yung ini-emit is alpha particles lang. Sa beta, yung ini-emit, so beta particles. Then, sa isomeric transition, yung ini-emit is gamma rays. Ito naman po sa internal conversion, yung ini-emit po is both gamma rays and characteristic X-rays. Okay? So, I hope that is clear. Now, let's go back to our presentation. So, electron capture or K capture. Nucleus captures an electron from an orbital shell of the atom. An electron from a higher energy level immediately moves into the vacant inner shell and fills the vacant position when the excess energy is emitted as characteristic X-rays. So, sa electron capture naman po, ito po yun. So, we will transfer again sa kabila. Erase mo natin ito. Erase. So, going back sa ating electron capture, nucleus captured an electron from an orbital shell of the atom. So, for example, we have here the nucleus. Ito yung nucleus natin. Ito po yung shells. Nakyan po natin ha. So, dahil masyado po siyang radioactive or mas madami po siyang number of protons, so mas strength po siya, mas strong siya when it comes to reaction or when it comes to ano? Yes, when it comes to attraction. So, dahil marami po siyang protons, radioactive siya, hindi po siya stable, ika-capture niya ang isang electron. So, i-absorb po niya yung isang electron. So, wala na po tayong electron dito. Pumasok na po yung electron dito, na-trap na. Dahil kulang, there will be filling up. Kung may extra pa po shell dito, may filling up pa din po. Because of this filling up, it will produce characteristic X-ray. Gets po ba? So, sa sobrang radioactive nito, na-capture po niya yung electron from the K-shell. Dahil, at saka i-absorb. Dahil kulang po ng electron, there will be, again, filling up, transition, or jumping of electrons from outer to inner shell. So therefore, when we say K-capture or electron capture, it produces characteristic X-rays only. So is that clear? So let us go back sa ating screen. So most likely, a K-shell electron is captured. That is why it is called K-capture. Outer shell electron falls into the inner shell or transfers the inner shell hole created with the captured electron. So, nung pumasok po siya dito, na-capture po siya. So, may bakante na po. So, i-fill up po niya. During the filling up, there is a production of characteristic X-rays, which may itself be absorbed and rejects an Auger electron. So, pwede po na ang characteristic X-ray na ito ay kusang lumabas. But sometimes, may mga occasions din po na instead na lumabas po siya ng diretso, pupunta po muna siya dito at i-eject ang electron na ito. Ano nangyari dito? So, katulad kanina ng ating internal conversion, na-remove po yung electron. Sa ating pong internal conversion, yung electron po is na-remove po ng gamma rays coming from the nucleus. This is internal conversion. Internal conversion or K conversion. Dito naman po sa Auger process, Auger po ang pagkakasabi niyan. Sa Auger process, it is the removal of the electron because of the ionization of the characteristic X-rays. Na-remove po ang electron dahil po sa characteristic X-rays. Sa K-conversion naman po, na-remove ang electrons dahil po sa gamma ray coming from the nucleus. Okay? I hope na gets po ninyo. So to summarize, so we have here alpha decay data, isomeric transition, internal conversion, and electron capture. So, alpha, so it resembles the helium element, has a charge of 2 and a mass of 4. It emits alpha particle. Beta minus, no change in atomic mass, so 0 ang mass, no mass, plus 1 charge. So, there is an increased number of neutrons in beta minus. In beta plus, there is an increased number of protons. So, the same sa dito, no change in mass. No change in mass. Ito plus 1 charge, ito minus 1 charge. Dahil lumanampas po ang number of protons sa number of neutrons. Next, isomeric transition. So, ejects conversion electron and occurs in a material that is in an excited state. So, it emits gamma rays only. Internal conversion or K conversion. The emission is gamma rays, and dahil kulang po siya ng electron, they will be filling up, therefore there is a reduction of characteristic X-rays. Then sa electron capture naman po, or K capture, so it emits only characteristic X-rays. Okay, so that is our summary. So what is characteristic X-ray? This is produced after the ionization of an inner electron and occurs during the filling up of vacancy of electron within an atom. So katulad po ng in-explain ko kanina, dahil po may ionization, dahil po may removal of electron mula sa inner shell, so kailangan po mag-fill up. So from the outer to the inner. Because of this filling up, it produces characteristic X-ray. Results from the transition of an outer orbital electron to an inner orbital shell. Transition or transfer or jumping of electrons from outer to inner shell. Dito yung Auger process naman, sinasabi po natin kanina, pronounced as Auger. Removal of electron by characteristic X-ray. Na-remove po yung electron dahil po sa characteristic X-ray. The removed electron is called the Auger electron. So, ito po yung diagram kung saan ang alpha can be stopped by a piece of paper or wall. Beta can be stopped by wood or aluminum or lead. Gamma rays can be stopped by lead. So, sa beta po, pwede pong lead, pwede pong aluminum. Sa gamma, lead lang po yung pwede makapag-stop sa kanya. So, dahil less penetrating siya, so sa papel po lang, wala na siya. Wala po siyang energy. Ito naman, moderate. So, kailangan medyo matibay, medyo makapal. So, aluminum or, wood or lead. Then, sa gamma po natin, dahil highly penetrating po siya, so it can penetrate both the paper and the aluminum, and it can only be stopped by a piece of lead. So, meron pa tayong types of radiation. Dali lang po. I will open for the video for you to see types of radiation. So, yan po yung ating differentiation between alpha, beta, and gamma rays. So what is the difference between gamma rays and X-rays? The difference is their origin. So the difference is their origin. Dahil ang gamma rays comes from the nucleus, while the X-rays comes from the orbital shell, katulad po ng pag-produce po kanina ng characteristic X-rays. The difference naman between beta particles and electrons is also their origin. So beta particles comes from the nucleus, just like the gamma, while electrons comes from the shell. Okay, so basta kung may question of difference between the X-rays and gamma rays, difference between beta particles and electrons, the answer is origin. So that concludes our fourth installment of our radiation physics discussion. So meanwhile, just go over this discussion so that you will be able to understand the succeeding lectures on radioactive physics. Okay, so thank you.